Alright guys, now that we've got the wiring all done for the ECU, now it's time to start configuring it and getting it set up right. I've kind of already pre-built one, did most of the troubleshooting, so I'll just kind of walk through how we get this working. What I'm going to be using today is TunerStudio. Using the most updated version of TunerStudio. My version might look different than yours. I am using a Mac, but hey, we're going to work with what we got. So let's get going. So here you can see I've already kind of built a base map. I got all these other little maps in here, but we're going to start with this one, the SC300 NAT base map V3. So we click, we open it. It loads your basic, first screen there. Now, what I already went through and did is I went through and I created a custom screen that I'm able to run in the car. This one's really nice because it lets me see everything that I want to see to make sure that the car is running right. And the way you can go through is you can actually, there's a video out there that talks about creating these, but the first thing you do is you're just able to go into designer mode, and then it gives you all these options for you to be able to change your screen however you want to and create new dashboards down here. We're not going to go into that too much right now. We're really going to talk about just really getting a good base map together for your NAT build. So we start here under basic load and settings. First thing we want to go to engine sequential settings. You can see how I've got it set up. Got the required fuel. What's nice, you can come in here, put in all the specs. I'm running 850cc injectors, number of cylinders for all that stuff, and what it'll do is it'll actually calculate your required fuel for you. Control algorithm, speed density, because I ended up switching over to MAF. Over to map. There are other versions, like if you're still using the MAF or whatever, but I'm sticking with speed density because I do have a map sensor that's actually built into the unit. Squirts per engine cycle, I left that unchanged, left all this unchanged. It is a 4-stroke engine, changes to 6 cylinders. It is an inline 6. Number of injectors 6. Even fire, and then again all your injector size, which it should feed in when you hit the required fuel. And then you look at your main inputs. As for your injectors, I use the first 6 injector inputs, so injectors A, B, C, D, E, and F. I did go fully sequential, which means that instead of it firing in a batch mode where it'll fire in pairs, regardless of the position of the piston, it's gonna fire at fire the injector at the exact time that it needs that fuel. And then down here it has the firing order. Now the one thing about this is this firing order really, you enter this in mainly for the injectors, but you need to make sure that you wire your injectors correctly. And what I mean by make sure is that your injector A output should go to your cylinder 1, your injector B to cylinder 5, your injector C to cylinder 3, and so on and so forth. Don't just wire A to 1, B to 2, C to 3, D to 4, because it's not going to run right. You'll get a quick sputter when you try to start the car, and it's going to outright and die because the engine is not firing the injectors in the correct order. Moving down the next one, general settings. Here's if you want to set up an extra map, a whole bunch of other information. I usually don't mess with this too much. It's usually set up just right. And then the rest of this stuff over here, at this point we really don't need. I did set a TAC output because I did wire directly into the TAC output, and then you're able to scale it to make sure your TAC is reading correctly with your ECU, because the ECU, if you have your TAC is not matching with your ECU, 9 times out of 10 your ECU is correct, your TAC is wrong. So this allows me to adjust it to the proper tachometer reading. So again, rest of this stuff you really don't need right up front, except for maybe these first two. Like I said, yeah, you can set a rev limiter and everything. I really just kind of, you know, my red line is 7,000, so I just set it 6,800 with a soft zone. But I really haven't messed with any of that too yet, because the car is I'm still trying to, I haven't got it fully tuned yet, and I'll let the tuner go through all that. Here you set up the injector dead time. This you're going to set it up based off of the injectors you get. And you'll be able to set this up as well as build your table, and you should have a table that they give you, especially if you're getting new injectors, of how it tested out, and you should be able to go through and fill all this in. And so you fill it all in, and that's going to determine how well your injectors are working, how they're opening and closing, making sure they're getting the proper amount of fuel. If you don't set these up right, when you start messing with your table, you're going to have all these problems where you're going to get inconsistent fueling as you change your fuel table. Everything else, again, I just kind of leave alone. Eventually I'm going to set up the flex fuel sensor, but right now I've got it disabled. But that's something to mess with if you want to do that. This is also another important tool right here, is your AFR table. So you want to make sure you set up your AFR table based on what you want your projected AFRs to be at your whatever your boost level is, and then you build your RPMs here at the bottom. What's nice is there is a tool, an AFR table generator, which will actually go through, and if you want to, you can put all your data in here. I basically stole a lot of this data from different folks off of the Lexus forums of kind of what my goal is for this car to perform, so I could get a peak power RPM, peak torque, and the RPM for that. And then I just click generate, let it generate the table that way. Eventually I might adjust it some, but one thing that's nice about this is how if you decide to run any type of fuel correction, it uses this table to correct your fuel. And then ego authority, ego control, this is where your fuel correction comes into play. And based on how you set it up, you can either have it use a table, oops, wrong table. You could have it use a table like this one I've set up here, or you can have it set up where it just if you want to, you can set it as authority table off, and then you can actually just put in these values of how much percentage you want it to add or take away fuel. You know, when do you what coolant level do you want it to happen, things like that. Now if you look at my table, I am not going to run a table like this forever. Basically this table was built like this just so I can keep the car in good RPM or good AFRs while I break it in. I'm not pushing the car hard, I'm not doing anything crazy like that. I just want to make sure the AFRs stay good while I get that first, you know, 300 to 500 miles of break in on the car. Once I get this all once I get the ECU all dialed in, probably the highest any value on this table will be is maybe 12 to 15%. There's 25% right here. That means you've got a really bad tune, and you shouldn't be running like something like that, especially in boost. Next is the VE fuel table. So now my table will look different from yours, but what it is you got your KPA down here. You want to make sure you have enough space down at the bottom to catch your idle, as well as enough up here to make sure you're able to accurately measure your peak boost. And you maybe want to have a little bit on top in case the engine overboosts a little bit, and as well as having your RPM down at the bottom. And yeah, my RPM, my red line's at 7,000, so I just went 7,500. So again, a nice little bit of buffer in case I do over rev a little bit, which I don't plan to do. And again, this table is still really rough. Again, just dialed it in real basic with a road tune, just trying to get those break-in miles done on a brand new motor. Once I get that all dialed in, next step is going to be to take it to a tuner, and he's gonna really do his stuff. And then the rest of this stuff we don't use either. Coming over here, this is probably the most important section, this ignition options and wheel decoder. So this is important because this is what's going to set up how your car fires, how your spark plugs fire. And you need to set this up right. Everything in here I have is pretty much the settings you will need for a 2J if you're planning to keep the distributor and do a coil on plug setup like I did with the VVTi coils. The only number that's going to change is going to be this number, and this number is going to change based on how you install your distributor. And I'll cut to a picture right now showing of how to how you can measure what this number is going to be right now. So you need to have it set up to that. Having it set up to that, set up that number right, it's going to give you a rough guess of what this number needs to be. From there, I think mine came out a little low. The car would start, but then once you put a timing light on it, what'll happen from there is you can adjust it a couple degrees either way to get it dialed in just right. You will need a timing light to really get this number perfect. And the best way to get this number perfect is to move over here, set it to fixed timing, have it at a fixed timing. In this case, I used 15 degrees. And what that does is if you put your timing light on and you're not reading 15 degrees, you need to either adjust this number up or down accordingly until you get this number, until you get 15 degrees on your timing light and matches with this number. And some people use 10 degrees, some people use 15. Use whatever number you feel comfortable with, but you want it to be a number that's close to what the car is going to idle at, so that you can step away from being in the driver's seat and actually go look at the timing light if you don't have a second set of hands. Rest of this, again, set it up later. You will eventually need to set up your knock sensor, but I'm not going to go through all that. You'll have a tuner be able to go through all that. Next thing would be the ignition table, and with the ignition table, this is just going to give you your ignition timing, and again, it's going to be based off of your pressure, your manifold pressure, and your RPM. And everybody's ignition table is going to look different. Mine is still a little conservative. What I ended up doing is I ended up stealing the ignition table off of my Celica. It's a 3S GTE. It has the same bore and stroke, and it's got a higher compression. So I knew that the ignition timing on that motor was going to be more conservative than my motor that I'm building for this 2J, because this 2J I believe is running somewhere between an 8.6 to 8.7 compression ratio. So it's a little bit more built for boost, which means I could run a little bit more timing too, because the compression is not as high. So but this is what I came up with. Moving on to the next one, here you've got your startup and idle. Most of this stuff up here, the warm-up enrichment and all this stuff, you're going to let your tuner mess with that. Down here, you're going to move into the idle control. Now for these NAT setups, the idle control valve that's on these SC300s, or at least on my SC300, is a stepper valve. Some people are used to those PWMs, but that's not what we're dealing with here. We got a stepper valve. It's a 6-wire stepper valve where 4 of the wires are used for the position, and the other 2 are, I believe, are grounds. So what you're going to need to do is you need to get in the manual, look at it, and you have to wire it a certain way. And if your stepper valve is not acting correctly, then you've probably wired one of the wires backwards. Because basically what each wire does is it defines a position that the idle air control valve is going to be in. And so you want to make sure you get that wired right. Now what I did is I did open loop. Closed loop is probably the best type of tuning for idle control. But like I said, I'm not a tuner right now. I used open loop because open loop is really simple. You're basically telling the idle air control that at this temperature, at this engine temperature, and it runs off of this table, at this engine temperature, I want to be at this position. And that's all I did. And you just kind of play with it until you finally get it to idle where you want to. Now, when you're using a stepper valve, at least the stepper valves on this motor, the highest value you can have on your stepper valve is, I believe, 255, and the lowest is 0. So 0 would be fully closed, 255 would be completely open. So as you can see, and you'll see with temperature, as temperature gets warmer, your valve doesn't need to be open as much in order to get that proper idle RPM. And so I played with mine. You're gonna have to play with yours and get it to go just exactly how you want to. But this is kind of what I did in order to make it work. Next, down in here, air conditioning idle up. You're definitely gonna need to set this up. You're going to need to wire your Megasquirt ECU into the AC. You're gonna have to have one end going into. There's two pins. There's the magnetic clutch pin, and there's the AC pin. You need to make sure you wire those in. The magnetic clutch pin is what turns on the AC, and the AC pin is the signal from the actual dash, from the controller, that's telling the ECU to turn on the magnetic clutch. Because the ECU for these cars, unlike a lot of other cars, is controlled by the ECU, or at least the AC is controlled by the ECU. So you need to make sure that you set this up. So you can see that my output, I ended up using injector J. My input, I used digital switch 3. And then you mess with that if you want to delay it, so that it gives some time for the car to idle up before it actually turns on the clutch. You can have it do things like that. These values down here I'll play with later. So if you're at a certain throttle position, it'll turn the clutch off. If you're at a certain vehicle speed or certain RPM, it'll turn the clutch off so you don't burn it out at those higher speeds, higher RPMs. So again, a lot of things that you need to play with, but just to let you know, for the SC300, the AC does run through the ECU for its control. Rest of these things you really don't need to mess with. Eventually you end up having to set up a boost controller, get a solenoid going. Most boost controllers, that I have run at the 19.5 volts, 19.5 hertz. So you're gonna have to play with that, or get your tuner to play with that. And then besides that, the only other thing that I really set up in here that you really need is your speed sensors. And with the speed sensors, the reason why I need to set this up is because what I ended up doing is I ended up taking one of these wires, one of these output wires, I ended up cutting it and putting it into the speedometer because I went with a different size wheel. And this is great because now what I can do is I can go through, enter this information here, enter a whole bunch of information over here. So like wheel diameter, if you're going bigger wheels, if it's on the drive line, which means it's on the transmission, or if the sensor's on the wheel, all of these things, you can put all these in, and it'll accurately give you a vehicle speed that I have like right here. And that same vehicle speed will then be output by using this down here. It'll be output on this output wire, and it'll be sent directly to the speedometer. Now our speedometers, the scale is like 4,000 ppm, which is pulses per mile. Play with it a little bit. They're not all exact, so you may be plus or minus a couple hundred ppm just to get it to be dialed in just right. What I did is I did that, and I used a GPS speed sensor on my phone to kind of make sure I got it dialed in correctly as I was driving. Lastly, over here, this is good for if you want to do boost by gear down the road. So I just entered it all in for just in case down the road. So what I can do is have the gears, put in all the gear ratios as well as my differential gear ratio, and what it'll do is it'll actually be able to, if I want to down the road, I can set up boost by gear, and it'll know what gear the car is in based off of speed and RPM, and it'll be able to know what the limit of my boost is in that gear. But besides that, that's about everything you need. If you need more information on actually using a Megasquirt ECU, there's a whole bunch of videos out there. I bought my ECU from DIYAutotune.com. It comes with a great informational or great instruction manual that you can actually run through. So take some time, look at that. The instruction manual is really going to help, and make sure that you wire this thing up right. Take your time, troubleshoot when you need to. Like I said, these MS3PROs, I really love this ECU. It's a great price, and it gives you everything you really need to make the car run right.
And one last thing that I forgot, you need to make sure you come up to tools here. You need to calibrate all your sensors. So here you need to calibrate your map. Right here, this is the setting for the built-in map sensor. It's built in the actual unit, so you set that up, you're good. This is if you want to run a barometric pressure sensor, which allows you to adjust fueling based off of elevation. Also too, you want to also handle these other calibrations here. So your thermistor tables, this is going to give you your coolant temperature sensor, as well as your air temperature sensor. Now your coolant temperature sensor, I mean, right here I have it set up to GM because I did have to add an additional temp sensor for the coolant temp sensor, because since I'm keeping the stock ECU in the car, you can't have the ECU from the Mega Squirt as well as the stock ECU run off the same sensor. Since it's resistance based, it'll throw off the reading. So I had to have two different sensors. So I have a GM one that runs the Mega Squirt, and I have the Toyota one that's strictly based for fooling the stock ECU. And then the air temp sensor, same thing. It's the same. It's resistance based, so you got to have a separate one. So I have a separate air temperature sensor on top of the air temp sensor that's for the stock ECU. Now the air temp sensor for the stock ECU is actually built into the MAF sensor. So when I kept the MAF sensor, that keeps the air temperature sensor as well.